everyone. We will continue again our classes on physics by distance learning. This presentation is for grade 12. We still at chapter 4, forces, vectors and moments. So in this presentation or in this lesson, we will go through some solving questions. We will try to solve some questions on your textbook. So please open your book on page 56. We will start from section 1 for question 1, and we'll go to 2, 3, 4 until maybe question number 5. So question number 1, as we can see in this slide, we have a parachutist weight 10,000. When she opens her parachute, it pulls upwards on her with a force of 2,000 Newton. So section number A of this question, draw a diagram to show the forces acting on the parachutist. So what we have here, we have a parachutist. This is a parachutist. The weight of this parachutist is equal to 1,000 Newton and acting downwards. So let us say this is F1, and when she opens the parachutist, when she opens her parachute, it pulls the parachute, it pulls upwards on her with a force equal to 2,000 Newton. 2,000 Newton. So this one, this one is, for example, F2. So there are two forces acting on the parachutist, which is F1. F1 is the weight, and F2 is the force of parachute. And this is the direction of the travel. Okay. On slide number 2, section B of this question, calculate the resultant force acting on her. So what's the total force acting on the parachutist? As we discussed before, there are two forces. F1 is the weight and the F2 is the force of parachute. F2 is equal to 1,000 pulling up, and the weight is equal to 1,000 and acting downwards. So the total force acting on the parachutist is F total is equal to F2 minus F1. F2, this is F2 with the force of the parachute, and this is F1, which is the weight of parachutist. So why it's minus? Because the two forces is acting in different ways. This one is acting up and this one is acting down. So F total is equal to F2, because F2 is greater than F1. F2 is 2,000 and F1 is 1,000. So F total or resultant force is equal to F2 minus F1. 2,000 minus 1,000 is equal to 1,000 Newton and acting upwards. The total force is acting upwards. Okay. So now if the parachutist is still under this force, so the parachutist is keep going up, because F2 is equal is greater than F2 is greater than F1. So the parachutist is keep moving up. So section C, what effect will this force have on her? What's the total effect of this force or the resultant force acting on the parachutist? This force will accelerate the parachutist upwards. So this force will make the parachutist move upwards, is keep moving upwards. So at the end, if the F2 is keeping greater than F1, F2 is still greater than F1, So the burst test will never get to the ground. Will never get to the ground. So now the question is, how can she get to the ground? How can the burst test get to the ground? Please try to think about this and answer. Try to answer by yourself. Okay, now we will move to question number 2. Question number 2 is on the same page, on page 56. In question 2, the ship shown in figure 6 is traveling at constant velocity. It's traveling at constant velocity. This is important. So, first section of this question is the ship in equilibrium, or in other words, is the resultant forces or the resultant force acting on the ship equal to 0? How do you know? How do you know? As we can see here in this figure, this is the ship is moving this way, or the front of it is this way, and we have 4 forces acting on it. First force is the engine force, is equal to 50 kilonewton, and there an opposite force to the engine, opposite force to the force engine is drag D. It's like what do you call it? It's frictional drag of the water on the boat. It's like air resistance. It's like air resistance, and it's always in the opposite of engine force. The second one, or the third one, is the weight of the ship. The weight of this one is equal to 1000 kilonewton, and there is another one on the opposite side is called upthrust U and the force U. So we have like 4 forces acting on the ship, and because this ship is traveling at constant velocity, so what we have here, constant velocity means this ship is in equilibrium, and no, there is no accelerating or not accelerating. Acceleration is equal to 0, or in other words, the resultant forces on the ship is equal to 0. Why? Because it's traveling at constant velocity. Section B, what is the upthrust U of the water, or what is the force U of the water? As we said, because this is under constant velocity, so all forces here, or the 4 forces here, is equal to 0. Resultant force is equal to 0. So since this one is 50 kilonewton, so this one is equal to 50 kilonewton. So this force, it will cancel this force, and this force, it will cancel this force. Then the summation of the forces on horizontal is equal to what? To 0. To make it 0, so this one, it must be equal to 50. 50 minus 50 is equal to 0. Same in this direction. The weight is equal to 1000 kilonewton, so U, or the force U, is equal to 1000 kilonewton. So this one is cancelled this one is cancelled this one, so the total, or the summation of all forces, is equal to 0. So the force of U is equal to the same as the weight, is equal to 1000 kilonewton, and the drag one is equal to, or same as, the engine force. Okay, now we will move to question number 3 on the same page. In question number 3, there is a stone or stone is dropped into a fast flowing stream. This is a fast flowing stream. It doesn't fall vertically because of the sideways push of the water. So the stone is moving something like this. Is not moving in vertical direction. There is an angle here, theta. Why? Because of the sideways push of the water, as we can see in figure 4.7. So in question 3, we need to calculate, first we need to calculate the resultant force on the stone. How many forces here? There are 3 forces, as we can see in this figure. The first one is W. W, it comes from the weight, is equal to 0.5 Newton, and the force U is acting this way and equal to 0.5, and the push of water F and is equal to 1.5. So we need to calculate the total of the whole forces or resultant forces. B, is the stone in equilibrium? Is the stone in equilibrium? So when the stone is in equilibrium, equilibrium means all forces equal to 0. All forces equal to 0. So please try to answer this question by yourself. Test yourself with this question. It's very easy. It's something similar to spider example. On page, I think 55. It's similar, yes. Now we'll move to question number 4 on page 58. As we can see here in this question, the person in figure 12 is pulling a large box. The same person tried to pull a large box by different ways, 2 different ways. The first way, or first figure A here, is pulling a large box using a rope. Use the idea of components of force to explain why they are more likely to get the box move, or the box to move if the rope is horizontal, like in figure A, than if it is sloping upwards. So we have 2 ways here. The first one is the force of pulling the box is in horizontal way. Here there's an F here, there's no theta, theta equal to 0, and here there is an angle between the horizontal and the rope. There is an theta here. So which one is easy or to move? Which one can move faster? As we can see here, the force here, the total force here is equal to F cosine theta. F cosine theta. And this one here there is no theta. So the total force is equal to what? To F. So what's the total force here? Is equal F cosine theta. F cosine theta. So with drop horizontal, the force pulling the box is F. The total force is F here. In B, with the rope at angle theta, the horizontal to the horizontal. So if there is an angle between the horizontal and the rope, so the horizontal component is equal to F cosine theta. F cosine theta. And what's theta here? Theta is always, or is less than, always is less than this one. Because of what? Because cosine theta is always less than 1. Cosine theta here is less than 1. So at the conclusion, or at the end, F1 here is always what? Greater than F here. this one is always greater than this one. So that's why a person in figure A is more likely to move the box easier than in figure B. Question number 5. On page 58, we have a crate is sliding down slope, or a crate or box or something sliding down a slope. The weight of crate is equal to 500 Newton. The slope makes an angle of 30 degree with the horizontal, as we can see here in this figure. So we have a box here with slope of 30 degree, angle with 30 degree with the ground or the horizontal line. So first section of this question, draw a diagram to show the situation. We need to draw the diagram. This is the diagram. This is the box with force or contact force acting this way, and with theta here is equal to 90, because this one, the contact force is equal vertical on the slope, so this one is equal to 90, and the weight of this box is equal to what? 500, and the slope makes an angle of 30 degree with the ground or with the horizontal line. So this diagram represents all the forces which act on the crate. The weight, the forces are weight and contact force of the slope. Section B, calculate the component of the weight down the slope. Calculate the component of the weight down the slope. So what's the component here? Is equal to what? F here down the slope, F is equal to F cosine theta. Where is theta? This one, F cosine theta. This is down the slope, so it's equal to 500 cosine 60. 500 cosine 60. How will you know that one is 60? Why this one is 60? Because this one is 30. The weight is always vertical on the ground, so this one already 90, and the total here, the total angle is here is equal to 180. So we have 90, 30, so this one already 60. So the amount, the total force acting on the component of the weight down the slope is equal to 250 Newton. Part C, explain why the contact force of the slope has no component down the slope. Why? The contact force, this one, the contact force here, has no component down the slope. Why? Because it's always at 90 degree. It's at 90 degree. So F cosine 90 is equal to 0. So this one has no component down the slope. Section D, what third force might act to opposite the motion? In which direction would it act? So we have a force here, friction. This one is accelerate down the slope, so the friction is acting where? This way. So there are like 4 forces. This is an acceleration down, this is the contact force, this is the friction, and this is the weight. So the next one, or the third force here is, the third force might act opposite to the motion, is friction, and the friction is up the slope, is always up the slope here. Okay, now finally we will move to work with example on page 58. In this example, a boy of mass 40 kg is on water slide which slopes at 30 degrees to the horizontal, as we can see here in this figure. The frictional force up the slope is equal to 120 Newton. So calculate the boy's acceleration down the slope. Take the acceleration of free fall G to be 9.81 m over s. Okay, so now as we can see here in this figure, there are three forces acting on the body or a boy mass, which is a contact force, weight, friction, and he will accelerate down, or the motion is down, he will move down, with angle theta is equal to 30 with the ground. So first step in this question, or in this example, we will draw a report diagram showing all the forces acting on the object, as we can see in figure 13. This is known as a free body force diagram, and the total forces, or the forces acting on it, they are, first, the forces acting on the body, there are three forces, which are the boy's weight. So this is the boy's weight acting down with angle theta with the ground. Here it's angle theta equal to 90, so this theta is 90 degree. So the boy's weight W is equal to 40 kg times 9.81 m over s. It's equal to 392 Newton. 392 Newton. So this is the first force. Second one is the frictional force up the slope. This one, F here. This another force here is equal to what? Is given in question, and is equal to 120 Newton and acting this way. Okay, so we need to calculate the boy's acceleration. As we know, acceleration here is given by resultant force over mass. The acceleration is equal to, or given by, resultant force over mass. So we need first to find what is the resultant force, or the total force acting on a boy of mass 40 kg. So the frictional force is equal to 120, and the contact force C at 90 degree to the slope. This is the third one. The third force is here with angle equal to 90 degree. Okay, now we'll move to step 2. Step 2 now is we are trying to find a resultant force on the boy which makes him accelerate down the slope. So we resolve the forces down the slope. We find their components in that direction. We will find their components in that direction. So what we will have here, we will have like a component of W First one is a component of W down the slope, this one, and W was equal to 392. So the force here is equal to 392 times cosine theta, and theta is equal to what here is 60. It's similar to previous example, because this one is 90, this one is 30. Three angles here is equal to 180, so this one already 60. So component of W down the slope is equal to 392 times cosine 60 is equal to 196 Newton. Component FF down the slope is equal to minus 120. So why it's minus? Why? Because the friction is up, the slope is here, and this one is negative down the slope, negative, because F is directed up the slope, and this one is down the slope, so it will be minus. The third one is component of C, contact force down the slope is always equal to what? 0. Why? Because this angle is equal to 90. Theta here is equal to 90. So we can say that N has no component down the slope, since we don't know the value of N. Step number 3 is to calculate the resultant force, or the total force acting on the body. It's equal to what? Resultant force is equal to 196 minus 120. 100, this one, the force the component comes from W, plus this one, the component comes from friction. So it's equal to 196 minus 120. So it's equal to 76 Newton. Resultant force is equal to 67 Newton. Sorry, this one is repeated, so ignore it please. It's repeated. The final step is to calculate what? We are going to calculate acceleration. Acceleration is equal, as we said before, resultant force over mass. Resultant force over mass. And this force is equal 76 over what? Over the mass. The mass is 40. So it's equal to 1.9 m over s. 1.9 m over s. Please try to solve this example again and understand everything here. So next class, inshallah, we are going to draw center of gravity. If you have any questions, anything you couldn't understand, please feel free to contact me. I am happy to answer your question, and thank you for listening.